The James Webb Space Telescope can add another cosmic accomplishment to its list. The Space Observatory has been used to confirm the existence of an exoplanet for the first time. The celestial body, known as LHS 475b and located outside of our solar system, is almost exactly the same size as Earth. The rocky world is 41 light years away in the Octans constellation. Previous data collected by NASA's Transiting Exoplanet Survey Satellite, or TESS, had suggested the planet might exist. A team of researchers led by staff astronomer Kevin Stevenson and postdoctoral fellow Jacob Lustig-Yaeger at Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, observed the target using Webb. They watched for dips in starlight as the planet passed in front of its host star, called a transit, and watched two transits occur. There is no question that the planet is here. Webb's pristine data validate it. Lustig-Yaeger said in a statement. The planet's discovery was announced at the 241st meeting of the American Astronomical Society in Seattle. The fact that it is also a small, rocky planet is impressive for the observatory, Stevenson said. Webb is the only telescope that has the capability to characterize the atmospheres of exoplanets that are the size of Earth. The research team used Webb to analyze the planet across multiple wavelengths of light to see whether it has an atmosphere. For now, the team hasn't been able to make any definitive conclusions, but the telescope's sensitivity picked up on a range of molecules that were present. There are some terrestrial-type atmospheres that we can rule out, Lustig-Yaeger said. It can't have a thick methane-dominated atmosphere, similar to that of Saturn's moon Titan. The astronomers will have another chance to observe the planet again over the summer and conduct follow-up analysis on the potential presence of an atmosphere. Webb's detections also revealed that the planet is a few hundred degrees warmer than our planet. If the researchers detect any clouds on LHS 475b, it may turn out to be more like Venus, which is considered to be Earth's hotter twin with a carbon dioxide atmosphere. We're at the forefront of studying small rocky exoplanets, Lustig-Yaeger said. We have barely begun scratching the surface of what their atmospheres might be like. The planet completes a single orbit around its red dwarf host star every 2 Earth days. Given that the star is less than half the temperature of our Sun, it's possible that the planet could still maintain an atmosphere despite its close proximity to the star. The researchers believe their discovery will just be the first of many in Webb's future. These observational results from an Earth-sized rocky planet open the door to many future possibilities for studying rocky planet atmospheres with Webb, said Mark Lampin, Astrophysics Division Director at NASA headquarters, in a statement. Webb is bringing us closer and closer to a new understanding of Earth-like worlds outside the solar system, and the mission is only just getting started. The first images. The first image released shows SMACS 0723, where a massive group of galaxy clusters act as a magnifying glass for the objects behind them. Called gravitational lensing, this created Webb's first deep field view that includes incredibly old and faint galaxies. Some of these distant galaxies and star clusters have never been seen before. The galaxy cluster is shown as it appeared 4.6 billion years ago. The image, taken by Webb's near-infrared camera, is composed of images taken at different wavelengths of light over a collective 12.5 hours. Deep field observations are lengthy observations of regions of the sky that can reveal faint objects. Webb's primary targets for the first image release included the Carina Nebula, WASP 96b, the Southern Ring Nebula, and Stephan's Quintet. Webb's study of the giant gas planet WASP 96b is the most detailed spectrum of an exoplanet to date. The spectrum includes different wavelengths of light and reveal new information about the planet and its atmosphere. Discovered in 2014, WASP 96b is located 1,150 light-years from Earth. It has half the mass of Jupiter and completes an orbit around its star every 3.4 days. Webb's spectrum includes the distinct signature of water, along with evidence for clouds and haze in the atmosphere surrounding a hot, puffy gas giant planet orbiting a distant sun-like star, according to NASA. Observing how the stars form in this galaxy allows astronomers to compare star formation in our own Milky Way galaxy. In the new Webb image, forming stars can be seen pulling in ribbon-like gas and dust from a surrounding molecular cloud. This material feeds the formation of stars and eventually planets. We're seeing the building blocks not only of stars, but also potentially of planets, said co-investigator Guido Di Marchi, a space science faculty member of the European Space Agency, in a statement. And since the small Magellanic Cloud has a similar environment to that of galaxies during cosmic noon, it's possible that rocky planets could have formed earlier in the history of the universe than we might have thought. A long future of observation. These will be just of the first many images to come from the Webb Space Telescope over the next 2 decades, which promises to fundamentally alter the way we understand the cosmos. While some of what Webb could reveal has been anticipated, the unknowns are just as exciting to scientists. We don't know what we don't know yet, said Amber Strawn, Webb Deputy Project Scientist for Communications at NASA Goddard. I think it's true that every time we launch a revolutionary instrument into space, like with Hubble, we learn things that completely surprise us, but do not cause us to sort of change our fundamental understanding of how the universe works. Hubble's 31 years have yielded a wealth of discoveries that couldn't be anticipated, and the scientific community views Webb and its capabilities in the same way. When comparing Webb's first images to other breakthroughs in astronomy, Webb program scientist and NASA Astrophysics Division Chief Scientist Eric Smith compared it to seeing Hubble's images after the telescope was repaired and everything snapped into focus. A lot of people sometimes see pictures of space and they think it makes them feel small, Smith said. When I see these pictures, they make me feel powerful. A team of people can make this unbelievable instrument to find out things about the universe revealed here, and just seeing that pride in the team and pride in humanity, that when we want to, we can do that. The universe has always been out there, said Jane Rigby, Webb Operations Project Scientist at NASA Goddard. We just had to build a telescope to go see what was there. Yeah, very similar feeling of maybe people in a broken world managing to do something right and to see some of the majesty that is out there.